everyone, I'm Won Lee. Today we will study important distribution of S square. S square is a sample variance. Variance concept is very important, okay? And especially it plays important role in analysis of variance. Let's see what distribution of S square is, how to get that. Sample variance S square, of course, obtained from theoretical sample. I say theoretical sample, capital letter, x1, x2, xn. I repeated, capital letter, random variable. So S square is a capital letter, random variable, also a random variable. And therefore, it has probability distribution function, right? The distribution of sample variance is essential because the concept of variance is needed in various areas of statistics. Variance is useful in risk control. Before knowing the distribution of sample variance, okay, we have to define chi-square distribution. Chi-square distribution is what? Theoretical distribution. So let's see chi-square distribution. For example, x1, x2, xn obtained from a normally distributed population. In other words, the population has x follows normal with mean mu variance sigma square. In that case, the sum of squared standardized normal variable, sum of squared standardized normal variables of each xi is defined as following a chi-square distribution with degrees of freedom n. What is degrees of freedom? Number of independent items. So let's see here. Let x be x1 standardized x1 square, standardized x2 square, standardized xn square, sum of them. Then, briefly, shortly, sum of I from 1 to n, xi minus mu over sigma square, okay? Short form has chi-square distribution, chi Greek letter, square distribution with what? Degrees of freedom n. How many independent items here? 1, 2, n, right? x1, x2, xn are independent. So even standardized and squared, they are still independent. So number of independent items is n here, okay? Its probability distribution function is fx, chi-square x, is gamma. And you don't have to understand this kind of a notation, and actually you don't have to memorize this probability distribution function, okay? Anyway, very complicated probability distribution function, x greater than, of course, 0, right? Because all items are squared, so never negative, positive. Chi-square distribution approaches to the normal distribution as n gets larger. That is what? How the normal distribution is important. Everything. T distribution, approach to normal distribution. Here, chi-square distribution, approach to normal distribution. That kind of thing can be proved in mathematical statistics. So anyway, you don't have to worry about. And let's see some distribution function graph. Degree of freedom 1, this function show us this shape. Degree of freedom 4, then its distribution is like this, skewed to the right. Degree of freedom 6, it comes smoother, okay? Becomes to normal. So degree of freedom is large, very large. It's like a normal distribution. Now, let's see. We cannot say about distribution of S square. Instead of S square, we use this one. N minus 1 S square over sigma square. Okay? What is N minus 1 S square? Is what? Summation xi minus x bar square, I from 1 to n, right? So this form is equivalent to this one, right? Xi minus x bar over sigma square sum. What is the difference between them? You see, x bar is substituted to mu. Instead of mu, you use this term, we use its what? Estimator, best statistic, okay? X bar. Difference, only difference is that. So let's see this one. How many independent items here? N minus 1, right? N minus 1, degrees of freedom n minus 1, and others not changed. Same form, same, what? Similar item. So it takes chi-square distribution, but with degrees of freedom is n minus 1. Okay? You, I don't think you have to memorize this one, but you have to understand this, okay? Since we will study this kind of thing later on. Given a normally distributed population with variance 10, find the probability that the sample variance is greater than 16.92 when a sample of size 15 obtained. Okay? What probability of S squared greater than 16.92 is, we change this one, S squared term, to this form. So m minus 1, 15 minus 1, 15 minus 1 over what? Variance is 10, 10, S squared. Then this side, 16.92, also change to this. Then this one follows what? As chi-square, okay? So probability chi-square greater than 23,688. 23,688. It is like, I think, here, here, 23,688. Then we can find the probability of this area, okay, from chi-square table. You can see that appendix of a statistics textbook. This area is like this, okay? Only, not many, but how many? About 10 many values. Degree of freedom here. So 23 degrees of freedom. Let's see again. What size? Sample size is 15, so not 23, 14. Okay, degrees of freedom 14 here. No, and just 23 over 23 around here. So what? I got 0.049. Okay, not 0.05, similar to that value, 0.046, a little greater than that value, this value, a little greater than that. So, okay, you understand how to use distribution of a sample variance and define definition of a chi-square distribution, and you have to think about as a distribution of a sample variance as a square, then you have to think about this shape, okay, a little changed. These are constant terms, so you don't have to worry about too much. All right. Okay. I hope you get this distribution of a sample variance. Okay. Thank you. Bye.